What is an arc length? Alright, so let me tell you really quick. So let's say we have this circle here with the radius of 5 inches. And this particular angle right here is 120 degrees. Now, if I wanted to find the distance around the circle, well, that would just be the circumference. So we have a formula for that. That is, the circumference is 2 pi r. Right? So let's go ahead and find that. So the distance would be approximately how much? Well, 2 times, we can use 3.14 for an approximation for pi. And then the radius, of course, that was given, so that's 5 inches. And we just grab our handy calculator. We're going to say 2 times 3.14 times 5, press equals, and we get an answer of approximately 31.4 inches. So that right there is the distance all around the circle, right? So 31.4 inches. Okay, but what if we were only interested in the distance from here to here? In other words, this section of it. Okay. That's what we refer to as an arc length. Okay, so obviously the circumference is not going to work anymore because it's just part of it, not the whole distance around the circle. So how do we do that? Well, we have a fairly simple formula, and it starts with an S, and that stands for arc length. And then the radius, just like the circumference formula, but then times theta. Now theta is just a Greek letter, and that theta is going to represent the angle measurement, or the angle measure in radians, not degrees, radians. So let's crunch it out. Let's see, the radius, we know that one was given, that's 5 inches. So we'll just plug and chug, but then the theta, well, we know the angle, it's 120. So I'll tell you what, let's write it here on the side. It's 120 degrees. But we want to convert this into radians. So we know that in 180 degrees, there is pi radians. Because remember, half a circle is just pi, the whole circle would be 2 pi. So half of it is just 180. So then here, we can cancel the degrees, bye-bye. We get 120 divided by 180 times pi. So in this particular problem, let's see. Well, we can cancel one of the zeros. We're going to have 12 over 18 pi. And we can reduce that, right? Half both of them at least. So that's 6 pi over 9. We can reduce both of them by 3. So we'd be left with 2/3 pi. Okay, so that's what we have here. 2/3 pi. So again, this is just a little bit of arithmetic here that we did. And let me erase it so we can clean it up here. So basically our arc length, our distance, is going to be, I'm going to multiply the 5 times the 2, that's going to give me 10 pi over 3 inches. Now this answer right here is exact. Now if we want the approximation, then just like before, instead of the pi, we're going to use 3.14. Okay, so we get our calculator. We're going to say 10 times 3.14 divided by 3, and that's going to give us about 10.5 inches. Okay, so that right there is the approximate distance from here to here, not all the way around, because remember, all the way around it was like 31 something, right? Okay, but that little piece, 10, what do we say? Yeah, 10.5 inches. Alright, so that's arc length, guys. So that's it. So, see ya.